Download this code from codegive.com, link in the description below. Understanding and handling 4xx HTTP status codes in ASP.NET Core Web API. 4xx HTTP status codes signal client-side errors. They indicate that the client, example a web browser, a mobile app, or another API, made a request that the server couldn't process due to something wrong with the request itself. This could be anything from a malformed URL to missing authentication credentials. Properly handling 4xx errors is crucial for building robust and user-friendly APIs. It allows the client to understand why the request failed and how to correct it. This tutorial will delve into common 4xx status codes in ASP.NET Core Web API, providing explanations, practical code examples, and best practices for handling them effectively. Overview of 4xx status codes. Here's a breakdown of the most frequently encountered 4xx status codes. *400 bad request * the server cannot understand the request due to malformed syntax, invalid parameters, or an otherwise unprocessable request body. This is a general-purpose error code and often requires more specific information to diagnose the problem. *401 unauthorized * the request requires authentication. The client must authenticate itself, provide credentials, to access the requested resource. This usually involves sending an authorization header. Unlike 403, the resource could be accessed if authentication succeeds. *402 payment required * reserved for future use. Historically intended for payment systems, it's rarely used in practice. *403 forbidden * the server understands the request, but the client does not have permission to access the requested resource, regardless of authentication. This is different from 401, even if the client authenticates successfully, access is denied. *404 not found * the server cannot find the requested resource at the specified URL. This can mean the resource doesn't exist, or that the URL is incorrect. *405 method not allowed * the HTTP method, example get, post, put, delete, used in the request is not supported for the requested resource. For example, attempting to post to a resource that only supports get. *406 not acceptable * the server cannot produce a response that matches the client's accepted formats, specified in the accept header. For example, the client requests application/XML but the server only supports application/JSON. *409 conflict * the request could not be completed because of a conflict in the state of the resource. Often used in scenarios involving optimistic locking or concurrency control. *410 gone * the requested resource is no longer available and has been permanently removed. Similar to 404, but signals that the resource existed in the past. Clients should not expect it to be available again. *411 length required * the server requires the client to specify the content length header in the request. *412 precondition failed * one or more conditions specified in the request headers, example if match, if none match, were not met. Often used for optimistic locking. *413 payload too large * the request body exceeds the server's limits. *414 URI too long * the URI, Uniform Resource Identifier, in the request is too long for the server to process. *415 unsupported media type * the server refuses to accept the media type of the request body, specified in the content type header. *422 unprocessable entity * web DAV, the server understands the request but cannot process the contained instructions. Often used when validation fails during a post or put operation. Asterisk 429 Too many requests. Asterisk the client has sent too many requests in a given amount of time, rate limiting. Asterisk 451 Unavailable for legal reasons. Asterisk the server is denying access to the resource as a consequence of a legal demand. 2. Implementation in ASP.NET Core Web API. Let's demonstrate how to handle these status codes within an ASP.NET Core Web API controller. We'll create a simple products controller to illustrate the concepts. 1. Setting up the ASP.NET Core Web API project. If you don't have an existing project. 2. Create a products controller. 3. Key handling scenarios with 4xx status codes. 400 bad request. Invalid request body. The post and put actions validate the product model. If the model is invalid, example missing required fields, price out of range, model state. Is valid will be false. Returning bad request, model state, automatically includes validation errors in the response, giving the client specific details about the problem. Null request body. Checking for null request bodies in post and put actions. This is a simple but important check to prevent exceptions. ID mismatch input. The put action verifies that the ID in the root matches the ID property of the product object in the request body. This prevents accidental updates to the wrong resource. 404 Not found. Resource does not exist. The get, ID, put, ID, and delete, ID, actions search for a product by its ID. If no matching product is found, not found, is returned. The example provides a custom error message to help the client understand the problem. 405 Method not allowed, less common in typical controllers, more relevant for routing configurations or custom handlers. If the client attempts to post to the get, ID, endpoint, which only allows get, the framework will automatically return a 405. You can customize this behavior with custom route constraints if needed, but the framework usually handles the basic scenario correctly. 422 Unprocessable entity, considered instead of 400 in some cases. While bad request, model state, is the common practice, you could choose to return unprocessable entity, model state, instead, to indicate that the server understood the request format but could not process the data due to semantic errors, validation failures. 429 Too many requests, rate limiting. This isn't directly implemented in the controller code, but it's important to consider for production APIs. Rate limiting is typically implemented using middleware or external services. I'll show an example middleware later. 3. Best practices and enhancements. 1. Detailed error messages. Consistency. Use a consistent format for error messages across your API. This makes it easier for clients to parse and understand errors. Clarity. Provide specific and helpful error messages. Avoid generic messages like an error occurred. Tell the client what went wrong and why. 2. Logging. Log errors. Log all 4xx errors on the server. This helps you monitor your API, identify common issues, and diagnose problems reported by clients. Use structured logging, like iLogger, to capture relevant context, example the request URL, user ID, and request body. Distinguish error levels. Use appropriate log levels, example log warning for 404, log error for validation failures. 3. Validation. Model validation. Use data annotations in your models to define validation rules. ASP.NET Core's model binding automatically validates incoming data against these rules. Custom validation. For more complex validation logic, create custom validation attributes or use a validation library like Fluent Validation. Early validation. Validate data as early as possible in the request pipeline to catch errors quickly. For centralized error handling, middleware. Global exception handling. Use middleware to catch unhandled exceptions and return appropriate error responses. This prevents exceptions from crashing your API and provides a consistent error format. Custom error responses. Create custom error response objects to include details like error codes, messages, and timestamps. This provides a standardized way for clients to handle errors. 5. API versioning. Breaking changes. If you introduce breaking changes to your API, example change the format of a request or response, use API versioning to allow clients to continue using older versions of your API. This prevents unexpected errors for existing clients. 6. Rate limiting middleware. Example To use this, register iMemory cache in program.cs. And then add the middleware to the pipeline. 7. Custom error response format. Example. Use this error response in your custom exception handling middleware. In program.cs. 4. Conclusion. Handling for XXHTTP status codes effectively is essential for creating well-behaved and maintainable APIs. By providing clear and informative error messages, logging errors properly, validating input data, and using centralized error handling, you can significantly improve the developer experience and the overall reliability of your API. The example code provided gives you a solid foundation for implementing these best practices in your ASP.NET Core Web API projects. Remember to tailor the error handling to your specific API requirements and consider using custom error response formats for consistency and clarity.